Greetings, the Astro 30 here yet again with something else to look at. This is a subwoofer amplifier. It's an REL Acoustics Limited, Brigand, Wales, UK. It even uses speak-on connectors, which is nice. So the complaint on this is it fries drivers. Well, that's pretty well going to be DC on the output. So in order to make this a little bit easier, I might actually take the whole assembly out of the cabinet. Uses hex screws, so that's going to be fun. So let me get the amplifier out of the cabinet and get the cabinet out of the way. With the amplifier removed from the cabinet, we can see a little bit better in here. It's a Class AB amplifier design. Here's the output stage here. And it's a linear power supply, linear transformer. There's the output wires from the amplifier. There's also a relay here, which I'm assuming just connects and disconnects the speaker when it's going into sleep mode. There's another little board over here which is to do with the power, AC power coming in. And this is just the control board where the pots and stuff are connected on the other side. We've got a thermal cutout switch here, and it's a fairly bog standard design of power amplifier. It's not really all that interesting. So what I'm going to do is I'm going to hook it up to the dim bulb just to see what's going on, and hook up a multimeter across the output terminals, and we'll see what we get. Alright, I've got it sort of propped up on the transformer there. Got the multimeter leads jammed into the output, and you guys can look at the meter whilst I turn this on. Apparently we've got no power at all. Okay, brilliant. That doesn't look too great to start with. Yeah, of course the fuse is blown. This doesn't look too good either. There does happen to be a spare fuse by the looks of things in the holder, so I'll just swap them over. It's going through a dim bulb anyway, so it shouldn't blow it. Alright, let's try that again. Fuses only blow for one particular reason, shorter transformers. So again, we're across the output, and again nothing is happening. There we go. Yeah, the voltage on the output is kind of a little high. Ooh, yeah, that's going all over the place. So the dim bulb's not glowing that bright. Why the fuse blew, I don't know, but I'm going to continue doing all my tests with the dim bulb so the fuse doesn't blow. So there's a fault on the amplifier. The brightness of the dim bulb keeps going up and down. Well, it seems to have stabilised at minus 2 millivolts or so. Okay. So there's nothing unusual going on at the moment. So I might connect a signal source. Nothing appears to be happening. So, okay. Well, now that it's stabilised, maybe I should hook it up to the oscilloscope and dummy load and just see what the thing actually does. Okay, got my new dummy load hooked up to the oscilloscope. Oscilloscope probe is on ×10. Yes, that power cord's kind of in the way, but yeah, we'll live with it for now. And I do not see any visible output on either of these inputs. Well, that could be a good indication that it's not amplifying anything. Right, well that's kind of annoying. We do indeed have a bad DC offset on the output. Keeps moving around, going up. The dim bulb keeps lighting up brighter and then dimming back out again. So obviously the amplifier is drawing current. I did actually check the output transistors on diode mode and none of them appear to be shorted, so the next step for this is to pull the power amplifier PCB out and just, you know, inspect joints and capacitors and components and junk like that. See what we can come up with. Because now we're up to 10, 11, 12, 13 volts DC offset. Yeah, and that's enough to fry any driver. Right, well I've got the power amplifier out of the chassis and there looks like a few cooked solder joints around here that don't look all that great. Plus this sticky white crap all over the board. Don't know what that is, probably something they cleaned it with. So first things first is I'm going to clean the underside of this circuit board with circuit board cleaner. Get rid of this bloody Loctite crap. And yeah, see what I'm looking at then. But if I look at the other side, yeah, we've got all this circuit glue crap. Oh, there's actually an IC buried down there too. Didn't know there was an IC buried down there, but it seems like it's all sticky. You got something stuck to the top of it. Anyway, I'll clean the underside of this up and see what we've got. Alright, it's a bit cleaner now. I might have to rework some of these solder joints because this one doesn't look all that great. Doesn't look like it's even connected. It's all cracked. This particular joint here looks like it's got a crevice in it. It's hard to see on camera, but yeah. Probably just need to rework some of these joints and then I'll test some components like transistors and stuff and see if we've got like a faulty component. Right, well I tested some components, transistors and stuff. They all seem to be fine. Resoldered some joints and, well, apart from an initial surge after a few seconds of power up, the output does have a steady about 1 or 2 millivolts on its output, so it's not too bad. I reckon it probably could do with all the little electrolytics in there being replaced. So having seen what the output on the meter is, I'm going to see if I can get anything on an oscilloscope. The quick answer to that would be no. There's no output. So I don't know what's happening here at the moment. So the circuit board is back out and there's a reason for that, because I wanted to do a little bit of reverse engineering on, well, how the input is getting into the circuit and what that IC is for. I even cleaned the top of the IC. It's a TLO71 op amp and it's being used as our input stage differential pair basically. So here's our reverse engineered schematic. I've only done the input stage because I'm not really interested in the rest of it at this point. We've got a 10 microfarad capacitor here where the input comes in, goes through a 12k resistor here. There may be a few other resistors on this 12k going to ground. Probably most likely will be, but I just didn't test for that. And comes into the non-inverting input of the TLO71 on pin 3. Pin 2 comes off of this feedback resistor 6.5k, which comes directly off the emitter degeneration resistors on the output transistors. And then there's a 390 ohm gain set resistor and a capacitor to ground. This gives us a gain of roughly 15. However, because the TLO71 is running on a plus minus 15 volt supply, which I have tested for pin 7 and 4, there is 30 volts there. So the chip is getting voltage, the overall gain will not be 15, it'll be a lot more than that, because the output goes to probably a couple of transistors to boost the output in a voltage amplification stage. So it can actually, the output stage of the amplifier can swing closer to the power supply rails, which is about plus minus 35 volt. Now if we have an input here, we should also have a signal here as well in the feedback path, because an op amp will always try to make both inputs the same. But if there's no output here on pin 6, well, that means possibly that this capacitor here is bad. So what I'm going to do now is I'm going to hook it all back up. I'm going to put it back in its chassis, and we're going to test with a signal tracer to see if we've got an output on pin 6. If we don't, then, or it's weak, then we most likely have to replace this 100 microfarad capacitor. So let me get to doing that. Alright, this is my convoluted setup. I wasn't getting any signal coming off of the passive mixer board here, for want of a better term. So I've directly injected the input to the pin that it goes into the amplifier. So we've got a nice decent strong signal there, 1 kilohertz. I've got a multimeter hooked up to the output measuring the DC offset, and I'll turn it on. And currently the meter is saying about 2 or so millivolt. So I'll probe pin 3. There's our signal. Pin 2. There's our signal, a little bit louder. Now pin 6. The signal is there, but it's weaker. It's probably the same as input pin 3. Actually no, it's a little bit weaker than pin 3. So yeah, the signal's coming out of the op amp, but it's weaker than the signal going in. So that would prove to me that maybe this capacitor here will need replacing. I'm going to replace all the electrolytics. This one over here is for the delay time constant for the relay. That one's the input capacitor. That one is the capacitor going to ground from the gain set resistor, and these two are for the plus minus 15 volt supply rail. This one I'm not sure what it does. So that'll be cause for concern. These two transistors are getting quite hot to the touch, and I'm not sure what they're for. So yeah, there could be another issue there. They shouldn't be getting that hot. But that's so far all I've found, and well, the output's not doing anything. We're still sitting around the 1-2 millivolt mark. So it's not, that meter should be up to about, 4 or 5 volts DC by now, with the input signal coming through, and it's not. So I'm going to have to do a little bit more investigation, but the first thing I'm going to do is I'm just going to replace all the capacitors. Probably only going to cost about $5 in capacitors, and then we'll move on from there. If that doesn't prove to fix the problem, then I'm going to have to look into something else, and as to why these transistors are getting red hot. I don't know if they're being used as series pass elements for the op amp. So if I actually disconnect the input signal now, so it's not going through the op amp, because the op amp was getting warm as well. But if I disconnect it so there's no input signal, I'll just see if things start to cool down. That'd be a no. I don't know why they're getting that hot. They could be series pass elements, because I found that the supply rails, pin 7 and pin 4, do not connect to the Zener diodes where they would normally connect, like the positive connecting to the cathode of this one and the negative connecting to the anode of this one directly. So it must be going through some form of series pass element in order to keep the voltage more stable and allow it to deliver more current. It is possible that this op amp may be drawing too much current, because it is getting rather hot, and yeah, I can't see why, so I'm going to turn that off now. So I'll have to do a little bit more investigation as to what these transistors actually do, because there's no schematic available for this, of course. So I'm kind of doing this blind. But I know enough now about what that IC's job is. I know how the circuit would be configured in my mind, and where things would connect. But the job of these two transistors, I don't know at this stage. But there must be some form of series pass element in between the diodes and the supply rail pins, because they're not connected directly, as I said. So that's what I'm planning on doing, is replacing all the electrolytic capacitors and going from there. I'm actually wrong. These two transistors here must be part of the VAS, or voltage amplification stage, because they don't connect anywhere to the supply rails. These two transistors over here next to the filter cap actually connect to pin 7 and pin 4 respectively. Now this is a BF423, which is a PNP transistor capable of a collector to emitter voltage of around 100 volts, and it tests funny in circuit, so I'll just quickly unsolder it. There we go. So when looking at the transistor with the flat facing towards you, it goes base, collector, emitter. So pin 1 is emitter, pin 2 is collector, and pin 3 is the base respectively. And it's just a standard bipolar junction transistor. It's nothing special. So now I'm going to test it out of circuit so you can look at the meter, and I'll go between the base and the collector, the negative probe on the base. Standard diode drop there. Now the emitter. That reading, apart from the beeper being annoying, doesn't appear right. And now if I swap the leads around, so now the negative is on the emitter and the positive is on the base, so that's like you're measuring an NPN, we get the same reading. That should not be doing that. I'll just measure it the correct way. Same voltage. The emitter voltage, or the drop, should be higher than the collector, and it is not. Let me just test the NPN transistor. So there's the complementary NPN transistor for it, the BF422. And the pin out is exactly the same. It's base, collector, emitter in that direction. So pin 1 is emitter, pin 2 is collector, and pin 3 is the base. So if I put my positive lead on the base and the negative on the collector or the emitter, we should see a diode junction, a voltage drop. Alright, so positive on the base, negative on collector. Well, yeah, we have a normal diode drop. That one's less, and that's the emitter. It's 0.37 of a volt, which is kind of strange. So if I do the same test and reverse the multimeter lead, so now the positive is on the emitter and the negative is on the base, nothing much happens. That's pretty much well normal. So that other transistor to test the same voltage in either direction on the base and emitter leads me to believe that that transistor has a problem. I can order a pair, the 422 and the 423 respectively, on eBay for around about 10 bucks for 3 pairs. So I might as well just do that and replace both of them at the same time. I haven't replaced the capacitors yet, so I don't know if this is going to fix the problem, but because these transistors were getting red hot, that indicates to me that there might be an issue with them. So I will go and get a set of those ordered. They're only coming from New South Wales, so they should be here within a week. Well, it's only been a couple of seconds for you, but it's been a couple of weeks for me, and the transistors I've ordered have finally turned up. Now I've got 3 BF422s, which is the NPN, and 3 BF423s, which is the PNP. So what I'm going to do is I'm going to pull out one of each, and we're going to measure them on the multimeter and see if we get any different readings compared to the old ones. I can almost guarantee 100% that we are. Okay, I'm going to start with the PNP, and I'm going to measure base and collector if I can get my leads to agree with me. Normal diode drop, base and emitter. Normal diode drop, and I'll reverse the base and emitter leads around nothing, that's normal. On the collector, nothing, that's normal. So that is a working transistor. I was right so far. Now to test its NPN counterpart and see if we get, you know, good diode readings there. So base and collector, normal diode drop, base and emitter, normal diode drop, and we can see that between collector and emitter we've got about 10 millivolts more, so we know where the emitter is. So I'll reverse the leads around. Base and emitter, nothing. Base and collector, nothing. That is also a working transistor. So beauty, we've got two working transistors here. So now what I need to do is to pop them onto the circuit board and see if we well, get a different operation of the circuit, like maybe it'll work. Alright, I've got the transistors in. I haven't soldered them in, I've only just got them sitting in there with spring tension against the holes. Hopefully it'll give a good enough connection just to, you know, do a test. The meter is on volts DC connected across the output. I've got it hooked up to the dim bulb, so I'm going to turn it on. I didn't hear a relay click then. Right, well I've got the relay to engage. The transistors weren't making good contact. However, oh dear. Yes, that's not good. There is a serious problem now. Well, the good news is that new transistor survived. The bad news is its NPN counterpart is just getting red hot. The dim bulb is glowing about half brightness and the relay refuses to turn on. So something around that transistor is drawing excessive amounts of current. I popped the old one, which is just over here, back in circuit, and well, it allowed the relay to turn on, but we still had a DC offset on the output. So considering that this new transistor that I'm putting in is getting red hot, and well, this old one is doing exactly the same thing, there's something going on here in the circuit that I just cannot find at this point in time. Could have another faulty transistor, like faulty output stage, but trying to unsolder these transistors to, you know, get a good decent reading on the meter to see if they are indeed bad is very difficult. Well, the plot thickens on this thing. I've got the board back out of the chassis because, well, it's easier to work on, and I was just doing some, you know, tracing around the circuit to see where this NPN transistor interacted with this op amp. I still cannot figure out how it's connected to it. But then I decided to test the output transistors again, and I found something rather odd. So this side's the PNP and that side's the NPN. That's a 2SD1047C, and this one is a 2SB817C, I think is what it says. Anyway, that's kind of irrelevant right now as to what they are. I just know that that's PNP. So the normal way to measure a PNP transistor is to put the negative on the base, go collector and emitter, and you've got a diode junction. Well, if I swap the leads around, put the positive on the base, I am also getting diode junctions between the collector and the emitter. And just so you know I'm not going crazy, that was the reverse direction measuring, and now if I measure the correct way, we get the same diode drops, which is unusual. And if I test its counterpart next to it the correct way around, normal diode drop on the collector, normal diode drop on the emitter, if I switch the leads around, I'm getting diode drops. And it's the same for the NPN side too. That's not right. And it's probably pretty certain that that one is also testing the same. So that's an NPN, so if I put the leads the wrong way around, yep, diode drop in both directions. Yeah, that's not right. I'm starting to now believe that we have a blown output stage, which could be the reason why it's drawing so much current. The thing to do with this would be to remove all of the output stage transistors, and I'll pop the NPN transistor back in here where it belongs, hook it back up in the circuit, because the drivers are still connected to the rest of the circuit, so it's still going to operate. However, there's a 333 ohm between both emitters of these drivers, so they do not connect directly to the output point, so this will not function on its own as an amplifier. If they had emitter degeneration resistors going to each point on the output there, from each emitter, then this would technically be a push-pull amplifier anyway, and we could, see if we could get a signal. However, what I will do is I'll remove the transistors, and I'll pop the NPN back in, and I'll power it back up and see if the short goes away, as well as test the transistors out of circuit. So that's going to be my next move, and this video is starting to get onto the long side. So I'm going to find eventually what the problem is in this video, but then I'll have to talk to the owner of this to see whether he wants to go ahead and replace all these 4 transistors if they prove to be a problem. So that's my next step, is to unsolder the output stage and continue on fault finding. The output stage is removed, which was a real pain in the ass, but I got them out. The current going through the dim bulb has limited right down, which is to be expected because something is driving the output stage hard on. However, these transistors test fine out of circuit, but now there's an additional problem. This poor little NPN transistor had smoke coming off of it as soon as I powered it up. It was getting boiling hot, so there's still a problem on the main PCB somewhere. And really the only things left are these 2 driver transistors, or maybe the op amp itself. But now there's an additional problem. This input board now no longer has an output signal, and I was wrong before when I said this was passive. It's actually active. There's voltage 30 volts coming up the yellow and the white wire into this connector from the main PCB. So there's a bunch of op amps and stuff here under this epoxy crap, because I found out I was getting an output signal, but now I've got no output signal. Things off at the moment, but if I probe across my pot, I do have a signal there. So I know that there's something going in. I'll just turn him on a second. Well, actually it seems to be boosting the signal with it powered up, but there's definitely nothing coming out of the red wire, which is the output. Unfortunately, I think this board is dead, which is going to make this whole entire thing non-repairable. At this stage, I mean, I could pull these drivers off and test them out of circuit, because I are testing strange across collector and emitter in circuit, but I don't think that's going to prove anything, considering there's no output coming from this board now. I think this thing is pretty much well done. And with another oscillator, I've just verified that it's not a grounding issue or something with the internal one. There's our signal on the input. There's our signal on the output of the pot. And on the red wire, nothing. I could set up an external power supply and pump power in to this board. The yellow wire is the negative 15 volt and the white wire is the positive 15 volt. There's a ground over here as well, so but I don't think it's going to prove anything. It's still going to show that we've got no output. And I've also verified that the input connector isn't like shorted across the ground and the output from the other board. It's not. So I don't know what I'm going to do at this point. Probably nothing, because if this board is no longer passing a signal out, well, the whole thing's not going to work even if I do repair the amplifier. So the upshot is I'm going to put the output stage back together because there's nothing wrong with it, and I'll pop that other NPN transistor back in, and it's actually a real shame I can't can't repair it because it would have been nice. But considering the input board is now completely dead, that's going to prove kind of a problem. So I'll just solder these output transistors back in. I'll most likely put it back in the cabinet and just forget about it. The NPN transistor I've already soldered back in. They're the new ones. I'm going to leave the new ones in there. I might make this, as we say in the industry, someone else's problem, because I'm not getting anywhere with it. All it's doing is increasing my frustration level. So yeah, I think that's how it's going to go. Last transistor, trying my best not to melt components with the soldering on. And everything's in so close proximity, makes it harder to solder. Don't think that one was quite soldered properly. I'd laugh if the power amp works now. Okay, everything's connected back up. Let me turn it on. Same problem. And the relay's not engaging now. But that transistor wasn't smoking this time, but it is getting hot. Okay, so that's going to be basically the end of this. So I'm going to put it back in the cabinet and give it back to the guy saying it's unrepairable. It's unfortunate, but it's the way it is. Anyway, I hope you found this video interesting. If you did, please remember to rate, comment and subscribe below. And I'll catch you in the next one. This is the Astro 30 saying, see ya. Have a great day.